What's up? I'm Vin, and today I want to show how to find reference angles. So we have some notes here, and we're going to go through 8 questions. And for the first question, we want to find the reference angle for this 100-degree angle here. Now, if you want to just have a set of formulas that you could use, just know that in quadrant 1, the reference angle is equal to the angle that we're looking at from standard position. And if we're in quadrant 2, the reference angle is going to equal 180 degrees minus the angle theta from standard position. In quadrant 3, we could say the reference angle is equal to theta minus 180 degrees, where once again, theta is the angle we're starting with. And then in quadrant 4, the reference angle is equal to 360 degrees minus theta. So if I use this formula for the first question here, I would have to first know that from standard position, a 100-degree angle is an angle that is going to be in quadrant 2. So if I'm looking at a quadrant 2 angle, the reference angle for this would be 180 degrees minus the angle theta, which in this case is 100 degrees. So the reference angle would be 80 degrees. But the way I like to do these questions is I just go by the definition. I try to really understand the concept. And if I were to sketch this out, a 100-degree angle from standard position, if I start here on the positive side of the x-axis, is going to go like this into quadrant 2. So there's my 100-degree angle, but if we follow the definition, a reference angle is the positive acute angle between the terminal side of the angle and the x-axis. So I would highlight the terminal side of the angle is where it ends, and it ends here in quadrant 2, and I would highlight the x-axis, and there's my positive acute angle. And then using a little bit of basic geometry, notice the x-axis forms a straight line, and if this piece of the angle is 100 degrees, how many degrees is missing to make a straight line? Well, there's 180 degrees on a straight line, so that missing angle would have to be 80 degrees. So that's how visually I know, and by the definition, that the reference angle is going to be 80. And if I follow that same line of thinking for the second question, I could go ahead and sketch a 175-degree angle, which is also going to land in quadrant 2. And we can label this here as 175 degrees. So the reference angle is the positive acute angle between the terminal side of the angle and the x-axis. So once again, I have a straight line, and if I have 175 degrees in this angle, the missing angle here would have to be 5 degrees. So that's my reference angle, 5 degrees. But if I want to use the formulas, I could just say the reference angle is equal to 180 degrees minus the angle from standard position, and this is the angle from standard position is 175 degrees. So when we simplify this, we have the reference angle is just 5 degrees. So now we move on to the third question here. You'll notice now that we have a quadrant 3 angle. So if I draw this from standard position, 220 degrees goes 180 degrees plus an extra 40. So that's where my angle would terminate here in quadrant 3. So 220 is going to be the entire angle. But we want to think about what is the positive acute angle between the terminal side and the x-axis. So in a sense here, you could see that we're ignoring the first 180 degrees. And to get to this angle here, to the 220-degree angle, we go 180 plus an extra 40. So that would be our reference angle. But if we just want to use the formula, the reference angle for this quadrant 3 angle is going to be the angle that we're starting with, 220, minus 180, which is also going to give us 40 degrees. So you could decide for these if you prefer to just use the formula or if you want to use the definition and visualize it to find the reference angle. So let's say for the fourth example, we only want to use the formula. Well, then the reference angle, we would use the formula in quadrant 4 since 310 degrees lands in quadrant 4. And the reference angle here would be 360 degrees minus the angle from standard position is 310 degrees. So our reference angle would be 50 degrees. So this would be our solution to the fourth one. So for the next 3 questions, I want to look at scenarios where your angles are bigger than 360 degrees or less than 0 degrees. And in situations like that, you want to find a coterminal angle. And the way you would find a coterminal angle for an angle bigger than 360 is you would just start subtracting 360 degrees from the angle until you wind up with something between 0 and 360. So notice if we subtract 360 from 510, we get 150 degrees, and this angle is a quadrant 2 angle. So now if we think about it, we could just use the formula here and jump right to the solution and say the reference angle, since this is a quadrant 2 angle, is going to be 180 degrees minus the coterminal angle is 150 degrees. So our reference angle is 30 degrees. So this is one route we could go. The other route, though, is just to understand the definition. That even if we use the original angle of 510, we could see that 510 degrees is a full 360 plus an extra 150 degrees. But the terminal part of the angle is going to be here, this line that I'm drawing in red. And remember, the reference angle is the positive acute angle between the x-axis and the terminal side. So remember, if the leftover angle, once we go one full revolution, is 150, then the missing piece here is going to be 30 degrees, which also gives us the same answer here. Our reference angle is 30 degrees. So once again, we could either use coterminal angles to answer the next question, or we could visualize things. If we go the coterminal angle route, we have negative 150. So if we have an angle less than 0, we could add 360 degrees to the angle. So I'm just going to write it as 360 degrees minus 150. So our coterminal angle, if we work this out, we're going to have, this is going to be 210 degrees here. And this is a quadrant 3 angle. So if I just want to use the formula, this tells us that our reference angle in quadrant 3 is the angle 210 degrees minus 180 degrees. So the coterminal angle concept is pretty helpful for these questions because it allows you to use these formulas here. But once again, let's say I would rather just visualize things. A negative 150 degree angle starts in standard position, but it goes clockwise 150 degrees. So the 150 degree angle would not be going this way to quadrant 2, it's going this way to quadrant 3. And I'm just drawing this out to help us visualize, but remember, the reference angle is the positive acute angle between the terminal side, which is where the angle ends, and the x-axis. So simple geometry here, if I have a straight line, I have 180 degrees, so if this piece is 150, this piece is 30. So that also supports why our answer is 30 degrees. And now for question 7, once again, I could use the formulas. I could find a coterminal angle, which we'll label as theta with a subscript c here, and I'm going to add 360 degrees to negative 80 degrees. So our coterminal angle, if we work this out, is going to be 280 degrees. So now we think about this, this is a quadrant 4 angle. And if I want to find my reference angle from a quadrant 4 angle, I'm doing 360 degrees minus my angle, but I'm using the coterminal angle here. And now what we have is our reference angle here is going to be 80 degrees. But the easiest way to do this question, to do question 7, is really just think about it. Negative 80 is 80 degrees going clockwise from standard position into quadrant 4. So once again, just think of the definition of a reference angle. It's the positive acute angle between the terminal side of the angle and the x-axis. So if I need my reference angle to be positive and acute, it has to be between 0 and 90. And all that's going to do here is get rid of the negative in our angle. So the positive acute angle here is going to be 80 degrees, which supports the answer we found doing this the long way. Now, the last question I threw in, because every now and then you just need a question that's so easy that it's difficult. But notice this is a quadrant 1 angle. And in quadrant 1, the reference angle is exactly equal to the angle theta because it's already positive and acute. So our reference angle here is 50 degrees. That's our solution to the last question. Okay, well, this is going to conclude this video on reference angles. If you found this video to be helpful, please like and subscribe. It really helps me grow the channel. And if you got any requests, just leave the topic or topics you want me to cover in the comment section below. And thanks for watching.